service call regarding a hot ground on a residential branch circuit in a house built circa 1970 revealed a complex issue. A builder using a fluke proximity voltage tester detected voltage on a ground wire, prompting further investigation. The electrical system was a mix of original wiring and recent additions, some not installed by a licensed electrician. Many 12mm2 with ground cables had their ground wires cut at the connector inside the electrical box, while others were properly connected. The fluke tester confirmed voltage on the ground wire. In a switch leg, a short run of 12mm2 wire connected a junction box to the switch box, with the black wire used as the line and the white wire as the load conductor. The ground wire was cut at the junction box but remained at normal length in the switch box. A multimeter placed between the line and the ground wire indicated a 60 volts reading. Several factors could explain this reading. Firstly, capacitive coupling could be at play. Capacitance between the hot line and the floating ground wire can create a voltage potential even without the physical connection. This is especially true if there's a nearby electrical field from other wiring or appliances. The floating ground wire acts as one plate of a capacitor, with the hot wire acting as the other plate. The insulation between them serves as a dielectric. This capacitance, although small, can allow alternating current to flow, resulting in a measurable voltage. Secondly, inductive coupling could be contributing to the voltage. Magnetic fields generated by the current flowing through the hot line can induce voltage in the floating ground wire. This is more likely if the ground wire runs closely parallel to the hot line over a significant distance. The ground wire acts as a secondary coil in a transformer, with the hot wire as the primary coil. The alternating current in the hot wire creates a changing magnetic field, which induces a voltage in the ground wire. Thirdly, a faulty meter or tester could be the cause. The fluke proximity voltage tester or the ampere multimeter might be malfunctioning or improperly calibrated. Before drawing any conclusions, it's essential to verify the accuracy of the testing equipment using known voltage sources or by comparing readings with another calibrated meter. Fourthly, phantom voltage, also known as stray voltage, can occur. Phantom voltage arises when there's a high impedance path between a hot line and ground. This can create a small voltage potential even without a direct electrical connection. These voltages are often caused by capacitive or inductive coupling, as mentioned earlier, and can be easily disrupted when a load is applied. Fifthly, consider the possibility of a wiring mistake. Even though the ground wire in the switch leg was cut at the junction box, it might be accidentally connected elsewhere in the circuit, creating a partial ground path. A thorough inspection of the entire circuit is necessary to identify any unintentional connections or shorts to ground. Sixthly, a ground loop could be present. If a ground loop exists in the electrical system, it can cause voltage to appear between ground wires that are not connected to each other. Ground loops occur when there are multiple paths to ground, creating circulating currents in the ground system. These currents can induce voltage in nearby ground wires. To properly troubleshoot this issue, several steps should be taken. Firstly, verify the accuracy of the testing equipment. Use a known voltage source to check the calibration of the fluke proximity voltage tester and the ampere multimeter. If either meter is faulty, replace or recalibrate it before proceeding. Secondly, visually inspect the wiring. Carefully examine all wiring connections in the circuit, looking for any signs of loose connections, damaged insulation, or unintentional shorts to ground. Pay close attention to the junction box where the ground wire was cut, ensuring that there are no stray strands of wire touching other conductors or grounded surfaces. Thirdly, perform a continuity test. Use a multimeter to check the continuity between the floating ground wire and other ground points in the electrical system. This can help identify any unintended connections or partial ground paths. Fourthly, measure the voltage under load. Connect a load, such as a light bulb or appliance, to the switch leg and measure the voltage between the hot wire and the floating ground wire. If the voltage drops significantly or disappears when the load is applied, it suggests that the voltage is due to capacitive or inductive coupling. Fifthly, isolate the circuit. Turn off the circuit breaker for the switch leg and disconnect the wiring at the junction box. This will isolate the circuit from the rest of the electrical system and eliminate any potential interference from other circuits. Sixthly, retest the voltage. With the circuit isolated, retest the voltage between the hot wire and the floating ground wire. If the voltage is still present, it indicates that the problem is within the switch leg itself. Seventhly, check for capacitive coupling. To minimize capacitive coupling, try routing the ground wire away from the hot wire. This will increase the distance between the conductors and reduce the capacitance between them. Eighthly, check for inductive coupling. To minimize inductive coupling, try twisting the hot wire and the ground wire together. This will cancel out the magnetic fields generated by the current flowing through the hot wire and reduce the voltage induced in the ground wire. Ninthly, consider using shielded cable. If capacitive or inductive coupling is a persistent problem, consider replacing the existing wiring with shielded cable. Shielded cable has a conductive layer that surrounds the conductors and is connected to ground. This shield blocks electromagnetic interference and reduces the voltage induced in the ground wire. Tenthly, consult a qualified electrician. If you are unable to resolve the issue yourself, it is best to consult a qualified electrician. A licensed electrician has the knowledge, skills, and experience to diagnose and repair electrical problems safely and effectively. They can also ensure that the electrical system meets all applicable codes and regulations. In conclusion, the voltage reading between the hot wire and the floating ground wire is likely due to capacitive or inductive coupling. However, it is essential to consider other possibilities such as a faulty meter, wiring mistake, or ground loop. A systematic approach to troubleshooting, including verifying the accuracy of the testing equipment, visually inspecting the wiring, and performing continuity tests, can help identify the root cause of the problem and resolve the issue. Always prioritize safety when working with electricity and consult a qualified electrician if you are unsure about any aspect of the troubleshooting process. Remember that working with electrical systems can be dangerous. Always turn off the power at the circuit breaker before working on any electrical components. Use appropriate safety equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. The most likely explanation for the voltage reading between the hot wire and the floating ground wire is capacitive or inductive coupling. However, it is also important to consider the possibility of a faulty meter, wiring mistake, or other factors that could be contributing to the problem. Further investigation is necessary to determine the exact cause and resolve the issue.